Okay, so this is matrices, and matrices is the plural of matrix, and a matrix is an array of numbers arranged in rows and columns. So for example, the Football League table, that's an example of a matrix. It's got rows that correspond to the various teams and columns corresponding to various information about those teams, games played, games won, lost, won, drawn, lost, goals for and against, goal difference, and points. So this is an example of a matrix, and this particular matrix is a 3 by 4 matrix. So that's the rows, 3 rows, and 4 columns. So remember, rows times columns is the way it's expressed. 3 by 4, 3 rows, 4 columns. And here's another matrix, which is a 2 by 3 matrix, 2 rows and 3 columns. And there are some rules about multiplying matrices. So first of all, if we write them down like that, the numbers, or the matrices that we've got to multiply together, we've got a 2 by 3 matrix that we want to multiply by a 3 by 4 matrix. Now, not all matrices can be multiplied together because they have to have the right numbers of elements in them for things to match up. And the rule for that is if you write down the dimensions of the matrices, so 2 by 3 and 3 by 4 next to each other, then if those two middle numbers are the same, which they are in this case, they're both 3, then that means that the matrices can be multiplied together. And we'll see why in a minute. And then the resulting matrix, the answer, will have dimensions that you can get from the outside numbers here. So the outside numbers are 2 and 4, so the result will be a 2 by 4 matrix. So a matrix with 2 rows and 4 columns. So let's have a look at how you multiply two matrices together. Well, basically, the first row in the first matrix is going to be matched up with the first column in the second matrix. So row 1 is going to be matched up with column 1, and in the result, that's going to give us row 1, column 1 of the result. So let's look at that. So I'm taking row 1, I'm taking column 1, and in the result, it's going to give me the element that's row 1, column 1. So those things kind of match up, row 1, column 1, to give you row 1, column 1. And what happens is we pair these off. So I've done an amazing animation here where I take that off and kind of tip it into the other matrix like that. Boom, 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 boom. And here you can see why the middle numbers have to be the same, because those when you pair them off have to match up. So there have to be the same number of columns in the first one as there are rows in the second one. So we pair those off, and what we do is we multiply them out. So 5 times 2 plus 3 times 4 plus 2 times 5 gives us 32. So the element in row 1, column 1 of the resultant matrix is 32. So I want you to pause the screen now, pause the video, and try and work out the rest of the matrix. Okay, so I hope you pause that. So the next one, well, it's going to be 532 matched off with 361. So row 1, column 2 paired off to give us row 1, column 2 of the result. So that's 5 times 3 plus 3 times 6 plus 2 times 1 gives us 35. And if you didn't get that, just review it, pause again, go back before you think about the rest of them. And then if you haven't done the rest of it, pause again and try and do it. And then the next one is row 1, column 3. So 5 times 1, 3 times 2, 2 times 9, add together to give you 29. Then the next one, row 1, column 4, gives you row 1, column 4 of the answer. 5 times 2, 3 times 3, 2 times 7 gives you 33. And then we're on to row 2. So we're going to have row 2, column 1 to give you row 2, column 1 of the answer. So these pair off as 6 times 2, 4 times 4, 1 times 5 adds up to 33. And then 6 times 3, 4 times 6, 1 times 1 adds up to 43. And then 6 times 1, 4 times 2, 1 times 9 adds up to 23. And finally, 6 times 2, 4 times 3, 1 times 7 adds up to 31. There you go. Now, here's a matrix, 5 minus 1, 3, 1, 6, 4. And I want you to think of it as representing x and y coordinates of a shape. So the first row is the x coordinates, the second row is the y coordinates, and the columns are each point. So we've got the point 5, 1 here, so that's 5 across 1 up here, represented by the point A in my diagram. Then we've got minus 1 and 6, so the point minus 1, 6 represented by B here, and then 3, 4, 3 across 4 up represented by C. So that matrix describes a triangle. And this is important because this is kind of the foundation for the mathematics that you might use at a higher level to create things like computer animation, because we're going to look at matrices that you can multiply this by to transform the shape. The first one we're going to look at is the matrix 1, 0, 0, 1. So I want you to pause the screen and then try and multiply 1, 0, 0, 1 by the matrix representing the triangle. And the result should be a 2 by 3 matrix. Okay, so if you've paused the screen, hopefully you've found that you get exactly the same thing as you started with. So that's because having the 1s here and 0s here is making all of the x coordinates the same, and having the 0 and the 1 here is making the y coordinates all the same. So that's called an identity matrix. So generally it's all zeros with 1s down the leading diagonal. So whether it's a 2 by 2 like we've got here, or a 10 by 10 matrix, generally an identity matrix will be all zeros except for 1s down the leading diagonal. And multiplying by an identity matrix just leaves everything unchanged. Okay, so here's another one, 3, 0, 0, 3. Try and do the multiplication and see if you can figure out what happens to the shape. Okay, so hopefully you did the multiplication and got that matrix, and that matrix is an enlargement of the original shape. So multiplying something that kind of looks like the identity matrix, but it's got bigger numbers than 1 in, will give you an enlargement. And in fact, it gives you an enlargement, in this case, of scale factor 3, with the enlargement centered at the origin, 0, 0. So it's a scale factor 3 enlargement with the center of enlargement 0, 0. And there it is, enlargement matrix. So generally, all zeros except for a number down the leading diagonal, and that number is the enlargement scale factor. Okay, so here's another one. Do the multiplication and then draw the shapes and figure out what kind of a transformation it is. And then hopefully you got that matrix, which is a reflection in the x-axis. The x-axis, remember, is the horizontal axis where all of the y coordinates are 0. So the x-axis is the same as the line y equals 0, horizontal line. Okay, the next one, perhaps you can guess what this does. Looks very similar to the last one. Pause the screen, figure it out. Okay, and then hopefully you got that, which gives you another reflection, but in the y-axis. The y-axis being the line x equals 0, because the x coordinate is always 0 on the y-axis. So it's a reflection in the y-axis. Okay, here's my favorite one, so it gets a lot more interesting. Cos minus sine, sine and cos of a particular angle, in this case 60. So I want you to try and do the maths on that and figure out what kind of a transformation that's giving you. Pause the screen and try and do that. Okay, so hopefully you paused it and you got that, which doesn't look particularly attractive, but then when we plot it, we get that. Now that is a rotation, as I've illustrated there. Just do that again. So it's going round there, and you can see the center of rotation is the origin, the point 0, 0 there, and it's actually a rotation of 60 degrees anti-clockwise. So generally speaking, a matrix like that, cos minus sine, sine cos of an angle, gives you an anti-clockwise rotation of whatever the angle is. So there we are, rotation matrix.